Hey class, we are going to learn to check if when you're given a relation, meaning an x and y relation, to see if it's a function or not. Okay, so here we go. Got some new pens the other day, so there we go. So to check to see if it's a function, first of all, let me read the definition of a function. It's right here. Functions are special relation, so a relationship between x and y, where every input has exactly one output. Well, when we're looking at an input, we're looking at the domain, the x values, or in other words, your x values, okay? And then when we're thinking about output, we're looking at the range, okay? The range or the y values, okay? So every x value has its own y value. In other words, you can think about this as x not repeating, okay? So what we're going to do is, so here's all these examples and different representations of functions. So the first one, what we're going to look at the domain. So you have 0, 5, 7, and 11. Nothing is repeating. Every input has its own output, so that's a function. But when I look at these coordinate planes, I have -4, -1, -1 again, so -1 is repeating, and then 5. Then this is what makes it not a function. Okay, so this is not a function, this is a function. When you have a table of values, you're going to just look, -3, -1, 0, 2, and -3. Nothing is repeating, so this is a function. But when I look here, -2, 0, 2, 3, and 2 again, this is repeating. 2 is repeating. So this is not a function because, well, 2 is repeating. So when you have it as a mapping, you have -3 goes to 0, -1 goes to 4, 2 goes to 7, and 4 goes to 4. All x values has only one y value. But when I look here, look, the -4 goes to 4, but looks like -1 goes to -1 and -1 goes to -7. It has two outputs. So whenever it has something like this is not a function, whereas this is a function. Alright guys, graphing. Look, what we want to do for graphing is we're going to, I'm looking for my ruler here. Found it. So what we want to do is we're going to do the vertical line test, okay? The vertical line just checks the x values on your graph. So this x value right here has only one output, 1 point in it. This x value here only has one output, and then all of them also have only one output right here, only one y value. Okay, so this x has only one y value and so on. But if I come to this one right here, if I draw a vertical line on this x value at, -3, it has two values. It has 1, 2. So this is why it's not a function. Okay? This is why this is not a function. Whereas this is a function, because every x value has only one y value. Alright, and then you have continuous graphs here, not just points. So you can do the same thing here. You don't, obviously you're not going to draw at all the x's, but just like somewhere here and there, you can just draw those vertical lines, and it only has one output here, and anywhere I draw, it only has one output. But if I look over here, I come over here, and then I draw a vertical line, and then you could see, it has two outputs. So, nope, it is not a function. Okay, so that's how you can check. Let's do, there's a bunch of examples here that you can try. I think I will skip these 2 pages I do want to go to some SOL practice right here on page 9. These are what maybe your standardized test questions might look like. Some are pretty straightforward, some you really have to think about what they're asking. But the concept is the same. X is repeating, it's not a function. X is not repeating, it is a function. Alright. So it says circle the tables that represent y as a function of x. So I look here, well this is definitely not a function because the negative 3 is repeating, so that's not a function. Here negative 2 is repeating, not a function. Here nothing is repeating. It's okay if the 5 is repeating on the y, that's okay, as long as there's nothing repeating on the x. So I'm going to go ahead and circle that. That's a function. And this is also a function. It's fine if all of my values are going to negative 1, that's okay, as long as it's not repeating on the x-axis. Okay? Alright. Relation h is shown. Does h represent a function of x? No. Why? Because negative 1 has two output. It has an output of negative 7 and an output of negative 1. It's okay if, for example, 0 has two inputs. That's okay if two numbers go to the same output. What is not okay is if you have one x going to two different y values. So this is not a function because x negative 1 has multiple outputs. Okay. Alright, so this is a question that I like it. It's just tricky the way they're asking it, so let's go ahead and read it. It says 6 points of a relation are shown. So 6 points, 1, 2, 3, 4, 5, 6 are shown. Remove 1 point on the graph so that the resulting relation represents y as a function of x. So for right now, it's not a function because you can see that this point right here, 1, 1, and this point right here, 1, negative 2, are messing it up. So what they're asking you is to remove one of them and then it'll become a function. I don't have to remove both of them because if I remove this one, point, let's call it point A and let's call this point B. If I remove point A, if that's not there anymore, then it ends up being a function, right? Because everything has its own. If I remove point B, this then also ends up being a function. So remove 1 point. All right, I'm going to remove B. So remove 1, negative 2 to make it a function, or you could remove point A. All right, last question. What? 1 second. Sorry about that. Number 4 says, what are all of the values of x that could result in this relation not representing y as a function of x? So basically what they're asking is, I have x here, which I don't know what it is, but what they're asking for is make a relation here that would represent not being a function. So I know that if x is negative 3, so if x is negative 3, it won't be a function because then your x would be repeating. X is 0, it won't be a function. If it's 3, 2, or negative 2, if I choose any of these numbers, then it won't be a function anymore because then x would be repeating. But you can choose any other number other than these. It's not like there are no other numbers. Anyway. But the question is asking, which one of these numbers can you put in here for it not to be a function? And that's that. Alright guys, thanks for watching. Wait, are there any other examples? No. Okay, thanks.